So, Ramesh, what's the big fuss about this ARM architecture procedure call standard? What's the big fuss?
So, the ARM architecture procedure calling standard. So, what exactly is it? Well, it exists because we write programs in different people write programs. We write assembly programs.
Okay.
You write an assembly program. John writes one. I write an assembly program. You write subroutines. You write a subroutine here. I write, this is John's subroutine A, I write a subroutine, and this is my subroutine, and we call each other, right?
Because we're friends.
We're friends. I call you, and maybe this subroutine, somewhere inside this subroutine, I make a call to you, right? And so we're saying this call, we can, if we both agree on what I'm passing to you, then
Okay.
everything is good. So
You mean like parameters?
Parameters. So we say, for example, if this says that I'm expecting two parameters, two inputs. I'm expecting two inputs, and you have to pass them. So we know that we have to pass it somehow, and we use registers to pass. Let's say, right? Registers to pass. So we have to agree on what registers you're gonna pass, and the standard helps us decide. The standard basically says that there is a rule that says how parameters get passed.
But I don't like rules. Do I have to do it?
Well, we'll see. If you are the writer, if you are John, and if there is a John routine here, right? If there was a John routine here, John sub B, right? If John calls John subroutine, then John can play however he wants. He doesn't have to play nice. But if John calls Ramesh's subroutine or Ramesh calls John's subroutine, then we have to agree on something. And that's what the rule helps. The rule basically helps us be coexist in the same software. That's the idea. So the first rule, as you clearly understood, is about passing parameters. It's about passing parameters. So the rule says that we have up to 4 parameters are passed in registers R0 through R0 to R3 in that order.
So if I have 2 in my case here, which ones would I use?
So clearly in this example, if there are 2 registers we are using, we'd pass them in R0 and R1. So R0 will be the first and R2 will be the second.
So we have to agree on that.
We have to agree on that, right? If I send you and I send them in the wrong order, then you could be totally doing this. Maybe your idea was that you're performing x to the power of y, and now you're going to do y to the power of x.
That wouldn't be right.
Right? We get completely messed up. So that's our first rule. Now, clearly, what happens after if it's beyond 4 parameters? If it's more than 4 parameters, we put them on the stack. Get put on stack.
Now, if there are 5 parameters, do they all go on the stack or just the 5th?
Just the 5th one goes on the stack, right? And for now, we'll not worry about how they get passed on top of the stack. Now, the second rule is we pass information back and forth. It's not just that I call you, but you send me a result.
I have to
back.
return something.
Exactly. So in some sense, we also have to agree on how information is passed back. If you have to return something, where will that come? Now we know that we can, in keeping with the notion of a function, functions only return one thing. A function is defined as a many to one mapping, right?
Okay.
So which means that I can only get one thing back. I give you many things, you give me one back. And so this one thing that I get should come in a specific register again. And so we agree that that register ought to be R0. So single result in result, which is our return value in R0. Right? So this lets us exchange. These two are about exchanging information.
Got
Now there are other rules. Like for example, if I am working on before I call you, I did some work. I did some useful work here, right? This is some work I'm working on, some stuff. Now the act of calling you should not destroy the work I've done. So I should be able to count on the fact that when you come back, this work can be continued. So our work, our state, if you will, we call this the state, is stored again in registers.
I see.
And this registers, we say, oh, if you want to do this, if you want to work on something, maybe you should put them in some registers that I am obligated to preserve.
Okay, so John is obligated to preserve the registers that you have in your save bucket.
in my safe bucket. So which preserves the state. That's what we say. So the third thing is about such an obligation. And the obligation says that registers R4 through R11.
Okay.
And in fact, if
No,
you
that's
have
it. That's
if you have
perfect.
all R11, then it's
That's
you
fine.
have. But R4 through R7, if you have just those, R4 through R11 must be preserved
Okay.
by the callee.
Oh, by me.
By callee,
Not
you are the
Ramesh.
Yeah, in this case, you are the callee, and I am the caller.
I see.
Right, I am the caller. So you have an obligation to preserve those registers.
Now, can I use R4?
You're welcome to use it. So the key word here is preserve.
Ah, I
Preserve means that whatever its value was when the call entered here should hold the same values on return. So preserve could be you can save and restore them on the stack, for example. Right? But you are welcome to use them.
So you expect me to preserve them, and I'm obligated to preserve them.
Preserve
And
them.
that's the essence of this rule.
This rule. Right?
Got it.
Do you think there's another rule?
Well, what about the other registers? You didn't talk about our 1, 0, 1, 2, 3, 12.
So the fourth rule is just like you have obligations, you also have some rights.
Ooh, I like that.
So you have some rights, and one of the rights you have is you can do whatever you want with R0 through R3 and R12. So these are we think of these as scratch registers. Right? You have the callee may modify them and not worry about and not restore them,
and not preserve them.
not preserve them.
Oh, I like that better.
Yeah.
It's faster.
So you can use them. Now, granted that maybe you should be nice and not mess them up, but that is your right to choose. You can have a right to choose to be nice, but you don't have to be nice.
Got it.